Good morning. So I will evaluate this equation to generate the general wave function of psi. So radial, hydrogen, and the P. So we will first determine the radial function. So let's begin. R, 4, and 3. The H, that will be 3 and negative 3. And yeah, okay. Then the phi will be negative 3, and the magnetic spin is negative 1/2. So, R, 4, and 3. So, N and L. So, our N value will be 4, and our L value will be 3. So, we have an equation that says J is equal to N minus L minus 1. So, we generate it from this. So, 4 minus 3 minus 1, we get 0 for the value of J. So, we'll write the formula for the R function. So, R raised to L, E, negative C, N minus A, summation, N minus L minus 1, J is equal to 0, P, J, R. So, J is equal to 0, so our B will be 0. So, substitute the given value. So, R is equal to R raised to 3, E, negative Z, R over N will be 4, or A, summation. No, I mean, it will be BO. Because we already solved the J. Then, we will normalize. So, 1 is equal to integral of 0 to infinity R star R squared dr. So, 1 is equal to, so we will substitute our values we get here. So, R, 3, E, okay, I'm sorry, R, negative Z, R over 4A, times R3, E, negative Z, R, 4A. Don't forget to write R squared. R. Okay, I forgot to write the BO here. So, R3, E, negative Z, R, 4A, BO, R squared dr. Then, we will combine this. 1 is equal to integral of, so BO is constant, so we will place BO outside the integral formula. So it will be like this. Then E is to ZR over 2A. R will be R raised to 8 dr. So we will evaluate this integral by getting the integral table. So, E alpha x n equal to n factorial alpha n plus 1. Then, we will evaluate it. So n will be the number we have here, so 8 factorial, and the alpha will be here, so Z over 2A, so n plus 1, so 8 plus 1, 9K. So we will get the 8 factorial will be 40,320 over z over 2a 9. And then we will transpose this to the other side so we can get BO squared. So, z over 2a 9. So, 1 over 40, 320 equals BO squared. So, we will square root this both sides so we can cancel the square. And then, so evaluating this, simplify, it will be 24 square root of 70 z over 2a to 9. So we have already our BO, so we will substitute. Substitute this to the one here. Okay. So R is equal to R3 E to say R over 4A 24 70 and 0, where is it? 7 over 2A 9 over 2. So here we go, we have the R for the radial function. Then we will next evaluate the H theta. So
1, 2, 3.
So we will evaluate this. So H theta will be sine raised to m summation of L minus m AJ cosine J. J is equal to 0, 2, and J equals 1. Okay, so our L and M will be 3 and 3. So we will use the absolute value in identifying or evaluating the H theta. So J is equal to K is equal to L minus M. So 3 minus 3 is equal to 0. So our H theta will be sine, our M will be 3, so 3 A O. Normalization. We say short equals. Okay. So 1 is equal to integral of 0 to pi H star H sine theta d. So we will substitute the given value. So summation of 0 sine 3 theta 3 AO times sine 3 theta AO sine theta d theta. Then we will simplify it by combining it. So AO will be placed outside because it is constant, so squared. And sine, it will be sine raised to 7 theta d. Note sine theta d theta is equal to negative d cosine theta. So, 1 is equal to, so we will evaluate that integral. So, AO squared, okay, to be negative cosine 7 theta d theta. And don't forget that the that the 7, the exponent will be also placed in here. So, okay, I almost forgot that I already evaluated it. So, let's continue. Okay. Then, 1 is equal to AO squared over 7 and negative cosine pi minus negative cosine 0. Yeah. So pi is 0. Then I will then I will evaluate the cosine. So it will be, so cosine pi will be negative 1, so and cosine 0 will be 1. So 1 is equal to AO squared over 7. So 1, negative, negative, so positive 1. So negative, negative, plus 1. So it will be 2. Then 1 is equal to 2 AO squared over 7. Then suppose, so 7 over 2 AO squared. So we will square both sides. 1 cell. Then it will be 7 or... Okay, I'm sorry. 7 over 2 is A. Then we substitute it before we have normalized this to this. So our H will be sine 3. Yeah, sine 3 then A 7 minus 2 over 2. Yeah, this will be our H. Yeah, and it's done. So in our part 3, we are solving the phi. So this is the general formula of getting the phi. Then I also have written the answers we got from R and H. So we will write the answers, all the answers, and including here. So 24, 7, and the H. And the phi, which is y over 2 pi e negative I, and our m will be 3 phi. Then 4k. So we will write our value for our phi. So here, so I just separated the positive and the negative. So we will normalize this to d tau. So psi star psi d tau, so equals to n squared. Copy this, or Again, we will write it again. 3. And then, we will now answer this by using evaluate. So, like full method. So, 1, 2, and here. And positive plus y 4 3 plus 3. Oh, I forgot. Positive, negative. So, will be negative. I'm sorry. Then, here. So, negative, positive. So, negative. And negative, negative, positive. Okay. And then, I have no marker. And then, note that so our I is equal to J. And equal to 1. And if I is equal, not equal J, it will be 0. So here, so positive means same, so 1 minus not same, 0. So, not same minus 0 plus same, 1. So, that is equal to 2n squared. So, our value for n will be n is equal to 1/2. So, yeah. So, we will square root both sides. Cancel, and then we have the value for our n. So, then we will substitute it from here. Substitute. Okay. So, I will erase first. What? Erase. So, 4, 3, negative 3, 1, 4, 3 plus 3, 4, 3, negative 3. So, this is our answer for our phi. Then, so I have limited space, so I will write all the answers I got from R, H, and P. Then I will arrange it also. I will have an answer like this. Over 2. So my answer from n, then 2 pi. So this came from the formula of P. Then I will next write the answer from R. Okay, then, and for the H, I will also write but it's still not done because I will still write the Euler's equation from this equation. So, I 3 minus E negative I'm sorry. 3. Okay. So how can we answer this? So we will use Euler's equation. So Euler's equation. So E plus positive I phi will be equal to I cosine phi positive negative I sine phi. So my equation for I will be minus E I 3 phi. So I will write each I cosine. Of course, I will write 3 because I am finding plus I sine phi minus because minus E. Oh no, I'm sorry. It's I cosine 3 phi minus it's phi minus I sine 3 phi plus. I'm sorry, it's plus. Okay, so there's room for correction. So I will cancel I cosine because positive, negative. So I will have the answer of 2 sine 3 theta. So you can notice that I has been disregarded. So my answer will be this. So we already have the. Oh, I'm so sorry again for. This will be minus. I'm so sorry. So again, my answer will be 2 sine 3 phi. And then, I will substitute my answer from this. Okay. So, I will write it again for clear understanding. So, I'll just replace my answer to 2 sine 3 phi. So that's it. Okay, we are already in part 4 in identifying the F orbitals. Okay. So in this, I've already written all my answers we got from R, from H, from phi. So now, we are identifying the magnetic spin, which is if it's alpha or if it's beta. So, my magnetic spin is negative 1/2. So, there are steps to identify if it's alpha and B. So, number 1. So, S Z is equal to negative 1/2, which is my magnetic spin, H bar, and beta. Next, number 2, beta is equal to beta MS. So, MS means 1/2, so negative. So, I will put negative here. Next, we will normalize. So, negative to negative infinity. Again, to infinity. Again, psi x y z dx dy dz, which is equal to 1. And then summation 1/2 and ms is equal to negative 1/2 is equal to theta ms 2 is equal to 1. So, betas again equals to 1. So, it's so easy. So, next, we will do the chronicle delta. So, I will write here. Okay. Delta. Which is equal to 0. Oh, I'm sorry. I mean 1. Sorry. And so, summation of 1/2 ms negative 1/2. I will just repeat this step again. Repeat. X, Y, Z, dx, dy, dz equals to 1. So, our beta is equal to negative 1/2. And lastly, so you already know, we will now say that for 3, negative 3, 1/2 will be, I will put it here, so 2, 24, 70, z over 8, 2. I just repeat all my answers lately. And now, my final answer will be B. Done and